Hello everybody and welcome to part 27. This part is going to deal with graphing equations, and I feel graphing equations is the single thing that makes math as powerful as, I make it seem. So what we have right here is an equation right here. And in reality, there's always going to be two answers that will always satisfy this equation. Two answers and two sets of points that will always satisfy this equation, two numbers. For example, when x equals, let's say, 7, y is going to have to equal to 4. So 7 and 4 are solutions of this system, are solutions of this equation, rather. 8 minus 5, you can think of infinite ones, really. There's really, in fact, there is infinite answers to the solution. So with that in mind, we can really have a broad horizon of different answers. So what we like to do is take our answers and actually graph them on a coordinate plane, and just analyze how it works there. Whenever you have two variables, there's always going to be an infinite amount of two sets that will always solve that equation. So let's graph a couple points that we'll be able to put on our graph. I'm gonna go with actually 2, 4, 6, and 8. So now 2 minus y equals 3. 2 minus y equals 3. And now what we have to do is find out what value of y will satisfy this equation. So we can substitute the 2 into the x, but now we have the y that we have to figure out. So what we're going to do now is subtract by 2 on both sides. We're going to get negative y is equal to positive 1, rather. And I'm going to divide both sides by negative 1 to get rid of this negative, and we're going to get y equals negative 1. So 2, negative 1 is our answer. So I'm actually going to plot this point. And what I'm going to do is I'm going to treat all these x variables as if they're on the x-axis, and all these y variable answers as if they're on the y-axis. And then we're going to notice a trend. So we're going to have 2, negative 1. I'm going to put that point right there. That's the point for that. And let's solve it for when it's 4. So 4 minus y equals 3. Well, logic will tell us that 4 minus 1 will equal 3, but let's solve it anyway, just to show you that this will be the answer. Negative y will equal negative 1, and then y will equal positive 1. So we were right in our thinking that y is going to be 1. So I'm going to plot this point on there too. 4, 1, 4, 1. Alright, and as you can see, there might be something that goes off in your head right now. If it doesn't, we'll do one more, and then it probably will. So make your guesses as to what this graph is going to look like, because it's going to resemble some figure. It always remembers some figure, and so just keep that in mind as you're doing the next one. So x minus y equals 3, but we're saying x equals 6. So 6 minus y equals 3. And what we're going to do is subtract by 6 on both sides, which will cancel this out, and then get negative y equals 3 minus 6, which is negative 3. And we're going to divide both sides by negative 1 to get this y positive, as usual. And we're going to get y equals positive 3. So then 3 is our answer right here. So when x is equal to 6, y is equal to 3. Let's graph that. And by graphing that, I mean we're going to find 6x and then move up 3. And then we have that point right here. Now, something should continue, like I said before, something should go off in your mind, and it's going to resemble some one-dimensional figure. One-dimensional figure. Well, if you know anything about math, and if you don't worry, well, that's what I'm here for. You'll know that one-dimensional figure can only mean one thing, so it was actually a joke. But probably none of you got that, because I'm a nerd. And, I was actually going to, sorry, going back on topic, I was actually going to try to solve this equation, but if you can see, 8, 5 right there, so there's no point even trying to. So 8, I'm going to graph this, is 8, going to go up 5. Alright, now something should really go off in your mind. Something should wah, wah, wah. It looks as if this equation is just a graph. Is a graph, duh. is a line. And you'd be right in saying so. So according to that theory, let's see the value of 7. Well, the value of 7 is 4. So if we graph this, we're gonna get 7 and then 4. That looks like that's on the line. let's see, let's try 5. So 5 minus what is equal to 3? 5 minus 2. 5 minus 2 is equal to 3, huh? That's on the line too. It should be on the line because this is what you call a linear equation. If you ever heard that expression before, a linear equation means that when you graph it, it looks like it's on a line. Look at that. All these points are on a line. I'm just going to get rid of this line real quickly to show something. And even if I had some outlier point, let's say I had -8. -8. Let's try that. -8 minus y equals 3. -8 minus y equals 3. I'm going to actually do this in red because that's how I did all my other work. Add 8 to both sides. Add 8. Add 8. Then we get -y equals 11. So y equals -11. Ooh, that was kind of foolish on my part for me to do that because that's actually not existent on our graph. Let's do -7 then instead. But it's good. We're getting a bunch of points. So -7 minus y equals 3. Alright. And we're going to add 7 to both sides. So +7 plus 7. Sorry for that bad handwriting. We're going to get 10. And then we're going to, divide both sides by -1. Divide both sides by -1. It's going to change it to -10. So -7 is -10. Huh. -7. -10. Even that appears to be on a line. If we can try to connect it, let's try to connect this. Let's try to connect one big line from this point all the way down to the -10. It works. This is on the same line. Now, what else this is good for is now we can actually, no joke, we can actually predict where this line is going to head. Oh, I'm still on the line tool. I want to get out of this line tool. We can actually predict. We can predict where this values of the function at different points. So based on this graph, I'm going to assume that at -2 it looks about -5. -2, -5. So when y is equal to -2, x should be equal to -5. Or when x is equal to -2, let's draw that. Let's write this. X is equal to -2. Y should be equal to -5. Is this correct? Y is equal to -2. Okay, -5. And let's see if this works. So if this is the case, then these two variables should satisfy the condition x minus y equals 3. It should satisfy x minus y equals 3. So x, -2 minus -5 should equal 3. Well, if we know anything about our negative units, is that we add these two, so it becomes -2 plus 5, which equals 3. So this line, graphing this line helped us predict where, what variable, what value this equation would be at certain variables. We can even go so far as to, let's do another one. Let's do -6. Well, no, that's a negative. I'm looking for a good one. Oh, let's do 0. When it says that when x equals to 0, y should be equal to -3. So when x equals 0, y equals 3. Let's try that. X equals 0, y equals -3. So x minus y equals 3. 0 minus -3 should equal 3. Well, +3, so 3 equals 3. As you can see, this equation, by graphing it, we can find an infinite number of points based on just a couple of points. Now let's clear all this. And let's do one more because the best way to learn pre-algebra is to continuously do things. So I'm going to think of a random equation. It doesn't. The beauty about this is it doesn't have to be a simple equation. We can really graph anything. Any equation can be graphed. Let's think. Let's do something, but I want to also show you something else. 3x plus 2y equals 8. We can even do complicated stuff like this. Now, let's say I'm going to be given a bunch of x values. So I'm going to be given a bunch of x values. I'm going to have to find these y values in order to graph the equation. Logically speaking, what I would do in that scenario is I would actually want to isolate y. Because doing so would mean that if you give me any value of x, I'm going to wind up getting you, in a pretty quick pace, the value of y. Because before we had to sit there and solve things. Now, if we just solve one, we're going to get many values of x, and we can just plug that into our, so to speak, our algorithm, and we can get our equation in the end. So now what we're going to want to do is isolate this equation for y. And I've already showed you how to isolate these equations, so I'm just going to silently do it, just see if you can follow through with this. So this is going to be 2 equals negative 3x plus 8, and we're going to divide by 2 on both sides. And then this is going to become y. These are going to cancel out. It's going to become negative 3 halves x plus 4. So this is our new equation. We're basically going to take 3 halves of x, multiply x by 3 halves. Actually, why is this? Come on, let me get this. Oh, whatever. So y equals negative 3 half x plus 4. Let's rewrite this up here. Y, my bad. Y equals negative 3 over 2x plus 4. Alright, and now we're going to get a bunch of x values, but it doesn't matter because since we've already figured out the value, we're going to figure out how to get from x to y rather quickly. We're going to be able to solve this equation pretty thoroughly. I'm going to simply just draw 3 points because I want to show that this can be done really simply. Or actually, let me do points that will easily go into here. So 4. I believe 4 goes into this equation pretty. Yep, 4 goes into it pretty nicely. 2 and 6 doesn't have to be in order. That's another thing I'm telling you. It doesn't. You can pick random points. That's the beauty of this, really. So let's do negative 3 halves, and 3 halves is basically 1.5. So negative 1.5, negative 1.5. I'm gonna make this negative 1.5 on my calculator, and we're gonna multiply that by 4, which is gonna get us negative 6. Then we add 4, which becomes negative 2. I'm doing this all math on my calculator. You should be able to follow along pretty thoroughly. So negative 3 halves times 2. That equals negative 3. Negative 3 plus 4 is 1. I believe it does. Let me see if my math isn't killing me right now. Times 2 is 3, so negative 3. Negative 3 plus 4 is positive 1. And 1.5, which is 3 halves times 6, is negative 9. Negative 9 plus 4 is negative 5. Alright, and a good check is going to be when we graph this, these should all appear to be in a point, appear to be in a line. So 4, negative 2, 4, negative 2, 2, positive 1. Well, that looks like it could be a line. 6, negative 5. Yeah, we did the math right because that's in a line. Now, what the cool part about this is, in theory, I'm going to throw this out there right now, you only need 2 points to graph. You only need to find 2 points of an equation to graph, but I tend to want to use 3 or sometimes maybe even 4 points when you're starting out in order to make sure you really know what you're doing. So I'm just going to draw 3, and what basically this says is since these lines will work on all equations, so I'm going to want to draw from here, go right here, but instead of that, keeping the same lines, I'm going to extend all the way to the end of this graph, and then keeping the same slope, I'm going to try to extend to this end of the graph, and see if we do this right. That looks about right. That looks about right. That's right. Alright, so then, as usual, we have to draw our arrows saying that these will continue forever in this direction, and they'll continue forever in this direction. And now we can predict solutions when stuff is, let's say I gave you 1. Now let's not do that. Let's do a whole number. Let's do it. I gave you 8. Well, 8 looks like it's going to be negative 8. So let's see if this is true. So negative 3 halves times 8 is negative 12 plus 4. Would you look at that? 8 is equal to negative 8. I'm going to leave you guys on that note. But a good way to really learn this is to try to graph some equations, and that's all I got to really teach you guys. This is probably the most important lesson. This is why it took 15 minutes, and it was all solid information. I hope you guys really understand the point and how we graph an equation. So that's about it for this part. In the next part, we're going to analyze something called the slope, which is how steep or how narrow something is, because we can have lines that go like this, we can have lines that go like this, we even have lines that don't even look like they're moving because they're so steep. And that's all for tomorrow. And we're also going to talk about the infamous 0 divided by 0. That is going to be our debate for tomorrow. And yeah, that's about all I have for you guys. So see you guys then.